the law of conservation of energy and efficiency practice questions. So in the first question, you can see it's quite involved. So let's take a look at each parts of this question individually. Okay, so part A. What is the gravitational potential energy of the shot as it leaves the hand relative to the ground? So what I think you should do is you set up a table, initial and final. Okay. The mass is always going to be 7.26 kilograms. That doesn't change. Initially, the height is 2 meters. Final, the height is 8.0 meters. And initially, the velocity is 15.0 meters per second. So A is, what is the gravitational potential energy of the shot as it leaves the hand relative to the ground? So EG equals mgh. M, we know, is 7.26. G is 9.8, and the initial height is 2 meters. This works out to be 142.3 joules, and therefore EG equals 140 joules with 2 sig digs. Now B says, what is the kinetic energy of the shot as it leaves the hand? Well, EK is kinetic energy, equals 1/2 mv squared. 1/2 m we know is 7.26, and velocity we are told is 15 squared. And when you do that, you get 816.8 joules. EK is therefore equal to 820 joules. C, what is the total mechanical energy of the shot as it leaves the hand? So let's just say E mechanical as it leaves the hand. Well, that's always going to be our EK plus our EG. We know EK is 816.8. We need to use the real amounts, and our EG is 142.3. You put them together, you get 959.05, which equals 960 joules. D says, what is the total mechanical energy of the shot as it reaches its maximum height? Well, mechanical energy anywhere is going to equal 960 joules, because mechanical energy doesn't change. So that would be D. Okay, so here are the rest of the question, E, F, G, and H. So again, let's open up a new page and see exactly what we need to do. So for E, we need to find the gravitational potential energy as it reaches its max height. That's our question. We know that's going to equal to mgh. The mass is 7.26, gravity is 9.8, and the max height is 8 meters. When you put that in your calculator, you get 569 joules, which equals 570 joules for 2 sig digs. F says, what is the kinetic energy of the shot as it's at its maximum height? Okay. A little tougher. Now EK at max height. Now, how do we do this? We don't know the velocity, okay? But we do know the total mechanical energy. We found out in the last question. It's 959.05 joules. And we know that EM equals EG in any particular time plus EK. Therefore, EK equals EM minus EG. We know that EM is 959.0. We know that EG at its max height, we just found it out right there. It's 569. Therefore, EK is 390 joules. G, what is the kinetic energy of the shot just as it strikes the ground? So in this case, we're looking for EK bottom. And when it reaches the bottom, there's going to be 0 potential energy, right? So at the bottom, so we could say at bottom, EG is going to equal 0. There's going to be no height left. Okay. That means that at the bottom, EK equals EM. Therefore, EK equals 959.0 joules, which equals 960 joules at the bottom. Again, because at the bottom, there's no EG left, so everything is made up of EK. H, apply the law of conservation of energy to determine the final speed of the shot. Well, we know the final speed is going to be the highest speed, right, just as it strikes the ground. So we know at that point it's going to be EK bottom is going to equal to 1/2 mv squared. We know EK bottom is 959, 1/2, 7.26 v squared. You rearrange, you get a v of 16 meters per second. No direction because we're talking about energy. So let's write down what we have. So for this question, we know the mass is equal to 2.0 times 10 to the 2 grams, which is going to equal to 0.2 kilograms. We know the height is 22 centimeters, which is 0.22 meters. And we know that as the pendulum swings, it's going to have its maximum EK at the bottom and its maximum EG at the top. So if the pendulum swings down, we can say that EG top is going to equal to EK bottom. EG top is going to equal to MGH, which is 0.2 times 9.8 times 0.22, which is equal to 0.4312 joules. And we want to calculate the maximum speed at this point. Well, maximum speed, we know this is EG top, so therefore we can say that EK bottom, where the maximum speed is also going to equal to 0.4312. Now we can take that up here. EK equals 1/2 mv squared. 0.4312 equals 1 over 2, 0.2 v squared. And you do the math and you get a velocity equaling 2.08 meters per second, which equals 2.1 meters per second for 2 sig digs. Now B says repeat if the efficiency is 94%. And what does that mean? Well, that means that EK is not equal. EK bottom is not equal to EG top because energy is lost. EK bottom is going to equal to 0.94 EG top, which is going to be 0.4053. Now we do the same thing. We say that 0.4053 equals 1/2 mass is 0.2 v squared. We get a v equaling 2.01 meters per second. Therefore, v equals 2.0 meters per second at 94% efficiency.